We can now recycle our 3D printed waste and turn it back into usable filament at home. Hello ladies and gentlemen, I'm Dan, and welcome back to my kitchen. Today I am testing something very new. The Creality R1 Shredder and the Creality M1 Filament Maker. Creality sent both of these over to me for beta testing, and I need to be very clear. These are extremely early prototypes. However, even at this stage, they're insane. The R1 shreds failed prints, supports, and scrap material, and even dries it to remove moisture. Then the M1 takes that shredded plastic and turns it back into usable 1.75mm filament. And this isn't just for PLA, this can also be used for PETG, ABS, or anything along those lines. So naturally, I started off super simple. Unboxing the M1 took 30 seconds. Setup was just as quick. You put the spool on, spin the locking nut, and you're ready to start your plastic journey. The system itself is really clever. The plastic and pellets go into the hopper, they go down into an auger where they're heated and compressed into an extruder. From there, you manually guide the filament through a series of arms, down into a cooling loop, and back up to the spool. It's basically one big circle, and it looks easy, but it's not. At first. My first attempts at feeding the filament were absolute spaghetti chaos. Pastafarians would be proud. I dumped in 100 grams of 100% raw white PLA pellets, which were included in the M1 box. Then I let it preheat for about 4 minutes. After that, I began the extruding process. Then came the most important part. Do not rush this. If you pull too fast, the filament stretches, thins out, and snaps. Once it's extruding, you should wait 3 to 5 minutes during the extruding process to ensure that the diameter stabilizes at the correct and consistent size. It should stay around 1.75mm on the readout screen. I locked it into the spool and began the winding. And this was the start of producing my very first homemade roll of filament. The filament extruding tube behind the spool is on a threaded rod that will guide the filament back and forth to keep the roll tight and consistent. After only a few minutes, I had my first roll, if you consider 50 grams a roll. Checking with calipers, it was only 1.58mm at the end, but the diameter was mostly solid at around 1.78mm. This is because as it runs out of material in the auger, it'll thin out, so the out of tolerance section needs to be manually trimmed off. I then threw this into my Creality K2 3D printer and started printing a benchy. And honestly, it looked great. It was clean, strong, and surprisingly consistent. It looked no different than regular store-bought filament, but this was just the start. Next, I added some blue master batch pellets that were included with the M1. Right away, this attempt went way smoother. I already had a feel for the process, so guiding the filament was much easier and way more controlled. No spaghetti disasters this time, but I could get better at the winding. I ended up with about 66 grams of filament, and just from looking at the spool, you could already see the difference. So of course, I threw this into the printer and ran another benchy. And yeah, it looked awesome. The layers had this really nice variation to them, almost like a marbling effect. At that point, I wanted to push things even further. So I made a larger batch, around 200 grams, and this time I didn't really follow any specific ratio. I kind of just added blue, yellow, and green master batch pellets and kind of hoped for the best. But this is where things get really interesting. As the filament was being produced, you could actually see the color shifting in real time. It would go from blue to green and then to these kind of muddy brownish tones and occasionally even hints of red depending on how everything blended together. It wasn't a consistent color, but that's not what I was going for. Every section of filament looked different. When I printed with it, the benchy came out with these layered color bands that almost looked intentional, like a gradient, but completely organic. So I scaled the benchy up to 200% to really show it off. And honestly, it looked incredible. However, at this point, I had only used raw pellets and no actual recycled filament. So then I needed to use the R1 shredder. It's extremely simple to use. I began by dumping my 3D printed waste poops into the shroud and then starting the shredder. This didn't take too long, but you have to be careful that you don't overload the shredder. The box below collects all of the shredded plastic. While it's not required, I passed the material through the shredder a second time to ensure it was all consistently shredded. After getting all of my shredded and dried plastic from the R1, I then mixed about 75 grams of recycled plastic and 75 grams of raw pellets. I then dumped everything into the hopper and started the process of making filament. The filament that started loading onto the spool looked incredible. It had this really nice gray-blue blend to it. It actually looked better than I expected right off of the spool. I test printed a benchy first, and it came out perfect. There was no under extrusion or weird inconsistencies. Then I moved on to a vase just to test something a bit longer, and same result, completely flawless. I'm actually really impressed with how nice this vase looks and the cool effect that you can get with this blended filament look. And it's also really nice to see that this is 50% recycled material that's in this plastic. So at this point, I wanted to slowly change the ratio to have more recycled plastic to raw pellets. And that's exactly what I did. I pushed it even further to 75% recycled to 25% raw pellets. This time I didn't add any extra color at all. I just wanted to see what the material would naturally do on its own. As the filament was being produced, you could already see the color variation forming. I printed a benchy first, and it came out amazing. The color transitions were super visible, but it was printed extremely clean with no issues. Then I stepped it up and printed this larger woven basket, and that came off the printer just as nice. I also had no issues or printing inconsistencies with this. So next I aimed for 100% recycled plastic. It actually worked out perfectly because I saved all of the support material that I had gotten off of my Doomicorn suit build. So I shredded all of this down in the R1 shredder and then let it dry at 50 degrees Celsius for an hour. In total, this was about 300 grams of recycled white PLA and then 10 grams of additives, with half being raw white pellets and then the other half being red master batch additives. So it was 97% recycled material. After dumping everything into the hopper and letting the M1 spool the filament, the result was a super clean, consistent red filament. Honestly, it looked way better than I expected for something that's almost entirely recycled. So I put this filament into my K2 and the test benchy came out flawless. The print looks like a regular benchy and the red was almost perfectly consistent throughout the entire print. Then I tried something a bit more complex and it failed. I did get a jam partway through. This is most likely due to some minor contamination that got itself into the filament and then jammed the extruder. I can also take the failed print and then shred it back down and use it in another batch of filament. For the final test, I went all in. I wanted to make a large roll of filament. I shredded a ton of white PLA support material. I then added a very small amount of raw pellets and black master batch pellets to dye the entire spool. After dumping in the material, I got the filament onto the spool and started winding. This process took about 45 minutes, but by the end of it, I had over 600 grams of filament. The filament looks incredible. For this test, I used my Creality SparkX i7 to see if there would be any effect on a non-enclosed 3D printer. So I loaded in the filament and started a test benchy, and it came out perfect. It was smooth, clean, and the black color was really consistent throughout the entire print. All in all, it was a great test. So naturally, I decided to go big, and I printed a Darth Vader statue. The base printed on the first try with no issues or failures. It looked amazing. However, the first attempt on the body failed right near the end. It was so close. And on the second attempt, it also failed early. Now, both of these attempts look really good. The extrusion looks really nice and consistent throughout both parts. After looking into it, I realized the filament diameter had gotten slightly oversized and led to a clog in the nozzle. This can definitely be avoided by monitoring the diameter readout and adjusting the traction and extrusion speed if the tolerance is starting to increase or decrease. To fix this, I measured the filament until it was 1.75 millimeters, cut it, and then restarted the print. The third attempt was perfect. The final print came out super nice. It had a really nice smooth surface, consistent extrusion, and a really nice solid black finish. You can even see all of the small details printed perfectly. And keep in mind, this is over 95% recycled plastic. I am extremely impressed with how well this worked. Throughout all of my testing, it is clear that the 1-to-1 ratio of recycled to raw material is the most dimensionally stable for printing. While higher recycled to raw ratios can work, it places stricter demand on material purity, as recycling is a highly complex process. This is why Creality recommends a 1-to-1 ratio for better stability and efficiency. Alrighty, so in conclusion, I have been 3D printing for almost a decade now, and these are the coolest machines I've ever used. Having the ability to take 3D printing scraps, waste, support material, poops, shred it down, dry it, and then put it into the M1 to produce your very own filament at home is just insane to me. Especially now, since there's so many multicolor 3D printers flooding the market, it's great to have the ability to take that plastic waste and turn it back into usable filament. I know that tool-changing 3D printers are becoming a lot more common and generate a lot less waste. However, these don't just have to use 3D printing waste. You can use any plastic, such as shredding plastic bottles down to make PETG and then generate your own PETG filament. And while this doesn't perfectly solve the plastic waste that is generated by 3D printers, it is a massive step in the right direction. So the question is, are these perfect? No. But these things are extremely promising for the fact that they are prototypes. I did not expect them to work this well. Personally, I am really excited to see how this machinery will evolve and get better because it can really only grow from here. And with all of that, I want to give a big thank you to Creality for letting me beta test these prototypes. I'm genuinely blown away by having the ability to make my own filament in my own house. I also want to thank you guys for watching this video. Links to the M1, R1, and the 3D printers I used in this video will be in the description below. I'll see you in the next one.